10-15 minutes so that before the end of the hour, so that everyone gets a chance to try some of these out first. And then we will go over any of these as well if you have questions on them at a later time. Okay, so go ahead and try those out. Okay, so here is the answers for the 9.6 practice. It starts on the back page here, and then I'll just continue going through it until we get through all of them. Some of those I might give less explanation for, especially the algebra that's needed for some of it, but still make sure you are working through this. Okay, so we have, for number 1, it says, for each problem, answer the following questions. What theorem allows you to answer this question, and how do you know that you can use that theorem? So we're trying to figure out the measure of arc CE. So that's from here all the way here. And so the theorem that we're applying here is, again, if you notice, the center is there, the perpendicular is here. This is telling me then that this is, once I know it's a diameter and it's perpendicular, I know that not only are these segments congruent, or they're bisected, but we know the arcs are congruent. So this is theorem 10.5 again. And then step 2, or the second reason, says, how do you know that this can be the theorem? And so the two things are segment BD is perpendicular, segment CE, that's what we saw here with the perpendicular symbol, and BD is a diameter, or segment BD is diameter. Okay, and now we go ahead and solve it. So it tells me here that 4x and then this is BE, both those arcs have to be set equal to each other. So 80 minus x would have to equal 4x, and then you're just solving that linear equation. So you add x, divide by 5, and you find out that x is 16. The question, though, didn't just say what is x, it said find the measure of arc CE, or the whole thing here. So once I substitute back in, I want to double that to get my final answer. So the measure of arc BC would just be 4 times 16, which is 64. But you want to multiply that by 2 or double, add 64 to it again, because you want the entire arc. So the measure of arc CE is 128 degrees. And that would be the final answer. Okay, that's for the first part. Second part says the measure of arc TV is 121 degrees. It also tells me that these two arcs are both 6, which tells me that they're congruent to one another. And so this is that theorem, the first one again, theorem 10.3 that we just saw on the front page. And that theorem tells us, because it's the same circle, or it can be in congruent circles, but in this one it's the same, and we have some congruent chords, RS is congruent to TV, we know then that the arc measures have to be the same. So arc RS would just be 121 degrees. Okay, so those ones hopefully not too bad. For number 2, it does get into the algebra, but first let's just apply which theorem we are applying here. And so it says write an equation. Actually, first of all, you know this is circle F, center F, and then you have a couple of things. We know AB is 12, CD is 12, and so is, then we have GF and also EF. Okay, so we have all these different measurements, and we have to now just kind of substitute into an equation to find it. So we know here that GF and EF, GF and EF are, so we have to write an equation to help us find what EF is. So if we look at our diagram, GF and EF will be equal to each other based on the theorem that we saw on the front page. It was theorem 10.6 that shows that when these two chords are equal or the same, and you have a perpendicular bisector, or it's perpendicular, you then know that these are equidistant, or the same distance away. So GF is equal to EF, and since we know what those two are, we can just set them equal to each other. X minus 5 is equal to the square root of x plus 1. And for part B, when it says, well, how did you know this? That would be theorem 10.6 states that the chords are congruent if they are equidistant from the center, which is what we saw from the diagram. And then when you go to find EF for part C, this is where the algebra comes in, where you do have to use FOIL and factoring. So this would not be on a quiz or a test here, but it's good practice for next year for Algebra 2 with trig. So when I start, I would square both sides because I'm trying to get rid of this radical. And once I do that, cancel, leaving you with just x plus 1 on the right side. But here, I'm not going to show the FOIL, but this is what you should get. X squared minus 10x plus 24, and then from there you need to get everything to one side. So we subtract the x, we subtract 1, and it's now x squared minus 11x plus 24 equals 0. This one we have to factor now, so we can use guess and check. Some of you use that x method to factor, that's fine on this one. The two numbers would be negative 8 and negative 3. So we write them into the parentheses, factors for each one, then we're solving each one, and you find two answers, x equals 8 and x equals 3, but make sure both of them work, because if you go back to the original problem, we can't take the square root of a negative number. So if any of these are creating this to be a negative or this left side to be a negative, because remember it's x minus 5 is equal to square root of x plus 1. We can't let either one of these make it so that a square root equals a negative number. And so when I substitute 3 in here, 3 minus 5 equals 3 plus 1, is that this is not 2 is not equal to the square root of 4, because we can't have a radical equaling a negative number. There's no way that would happen unless a plus or minus was already written in here. So this means that x equals 3 is actually extraneous, and the only one that does work is this x equals 8, which you could check again if you just did x 8 minus 5 is equal to square root of 8 plus 1, and that does check out to be true because the square root of 9 is 3. So the final answer finally is if x is 8, then you can substitute that back in to find out what EF would equal. So when I go to substitute in for EF, which was square root of x plus 1, x is 8, so we just do the square root of 8 plus 1. Since the square root of 8 plus 1 would be 9, final answer is 3. 3 units is how far, or what EF would be, and same with what GF is as well. Okay, and then finally, the last page, we have two examples. Number 3, we can look at the diagram to help figure out, but 4, the answers will vary on this last one. If you have questions on this, I can go over it in person, because depending on what you came up with, your setup would be different. But this last one, number 3, says in the circle K, BD is congruent to HF. So we know the chords are congruent here, and it does tell us to write in simplified radical form as needed, and this diagram is not drawn to scale. So some of the measurements we know here is measure of angle 2 is 60 degrees, and AK, which is this measurement here, is 12, and it wants us to find MK. So a couple of things that we know now. If AK is 12, that's the radius. So I now know all the radii in this diagram are going to be 12. And then I know the 60-degree angle there. So another radius in this diagram would be FK. And so this would also be 12. So if I look at just this diagram here, I have a 90-degree angle here as well because there was already one here. I'm going to just draw this triangle right here. We have a 90-degree angle, a 60-degree angle, and this hypotenuse is 12. And so if I'm trying to figure out what is MF, that's this bottom part here, I actually have a, this is a special right triangle. This is a 30, 60, 90 triangle. So I can use my special right triangle rules because, again, the reason I knew that AK was equal to FK is because they are both radii and they have to be the same. But now if I think back to my rules from trig, the hypotenuse is always cut in half for my short leg. So MF would just be, I'm sorry, that's not my short leg. This is my short leg. This would be 6 and then the long leg here would be across the 60-degree angle, which would have to be 6 root 3. So final answer here, MF is 6 root 3. You could use sine, cosine, tangent instead. If you knew one of the other sides, then you could use Pythagorean theorem, but easiest is special right triangles on this one. Okay, and finally the last one says if BD is 12, that means that whole chord is 12, and AE is 20. Now AE is the diameter, that means the radius is 10. Okay, so if it tells me this information and I want to find what KJ is, KJ is right here, this segment. So I would use a couple of different things here. We will use Pythagorean theorem again, but just kind of deal with one triangle at a time is usually the easiest thing to do. If I wanted to though, I can just connect 2 points because K is my center. I could just connect it with D and I know the radius here is 10. So I'm looking at this triangle where it told me that BD originally was 12, and so these are bisected because of that perpendicular and with it being that chord. So once I know that they're bisected here, then this means this is 6 and 6. So if I know those are 6 and 10, I could just use Pythagorean theorem to help me figure out what this is KJ. This was J and K. J up here, K down here. And this one's D. Okay, so we would do Pythagorean theorem, and or this is a Pythagorean triple actually. That's the quickest way to find the answer. It is a 3, 4, 5, where it's been multiplied by 2. So 6, 8, 10. That means that the other leg would have to be 8 units for KJ, or JK, whichever way you choose to write it. Okay, so that's it for this practice of the back page of the notes. If you have questions, just kind of bring them and we can go over them at a later time.